Good day, everyone. My name is Kaide Daniel Akila, and basically, this is my project, which is the Zero Knowledge Password Manager. And this presentation will walk you through the motivation behind the project and obviously literature reviews, as in the related works, the design, the architecture, and as well as the results. But before we start, we need to ask ourselves, what is zero knowledge proof? Now, a zero knowledge proof, or a ZKP, is a cryptographic technique which lets someone prove that they know a piece of information like a password without actually revealing what that password is. And basically, zero knowledge proofs have three properties, which is completeness, which means that if you know the secret, then your proof always works. Additionally, we have soundness, which means that if the statement is false, no one can trick the verifier or the system into believing that your secret is true. And as well as zero knowledge, which basically means that if the system or the verifier learns nothing beyond the fact that the proof is valid, so it never knows your actual password, it only knows the proof. And that is essentially what zero knowledge proof is. Now, in terms of what the problem statement is, in today's digital landscape, basically the biggest weakness is still passwords. Users reuse them, they choose weak passwords often. Often they also leak their own passwords, and a single password can compromise a lot of systems. And basically, if the database is hacked and compromised, then a lot of information can be leaked and stolen. Often in traditional password managers can often be attacked by brute force attack and breaches. And basically, even biometric advancements such as biometric authentication, which look modern and are very advanced, can also be susceptible to spoofing or breaches as well. And account recoveries are also a major weakness as well in some password managers. The core problem that we are trying to solve is, how can we create a password management system that maintains zero server side knowledge while providing secure biometric authentication and a very good recovery mechanism. Now, basically, why zero knowledge proof? Now, the whole point, if I was to sum it down into a few words, is we do not want server-side encryption. Server-side encryption can lead to a single point of failure, and zero knowledge proof basically gives client-side encryption. Now, zero knowledge proofs, or ZKPs, are a way of proving you know something without actually revealing the secret, like I've mentioned. So, example, I can prove that I know a password, but I never have to send that password across the internet. The password or the plain text is never sent onto the database or into the server. Everything is always client-side encrypted. And why zero knowledge proof? Basically, they're just a growing digital threats and data breaches. Passwords alone are weak, and what I try to do is, my project combines three main ideas, which is zero knowledge authentication, so that the server never learns your password, as well as biometric integration. I integrated fingerprint and face recognition, and as well as Shamir's secret sharing, which is actually a recovery system, which I will get to, and which it lets us recover our account while introducing shares, which I will show you later. And basically, a simple reason why we are using zero knowledge authentication is so that our password manager can protect secrets or credentials, even though our server has been compromised or hacked or breached. And why it matters, basically, my motivation to create this system is to just address challenges. Users need protection. Their passwords or biometrics never leave the device in raw form, and that's the reason why I've chosen this project. Biometric authentication is convenient. But in this project, we've combined biometrics with zero knowledge proofs, so that even if you log in with your biometrics, the proof still needs to be verified before you can actually log into the system. For recovery, basically we've used a distributed recovery system with Shamir Secret, and this lets you distribute your recovery shares among trusted people or among various emails that you may have, so that there's not one single point of compromise in the system. And basically, yes, we combined all these so we can have a secure and safe password manager. Now, basically, going into the literature review, this is just what some people have come with. Basically, traditional password systems are vulnerable to brute force attacks, dictionary attacks as well. Brute force attacks and phishing and data leaks make passwords unreliable. Multi-factor authentication reduces unauthorized access and is very good for an extra layer of security. But they can also be vulnerable to sophisticated attacks such as phishing and social engineering. In terms of biometric authentication advances, basically, biometrics are common these days in devices, especially fingerprints and face recognition. However, in unimodal systems, it's limited to single point failures, and spoofing attacks can obviously bypass unimodal systems. Multimodal systems combine multiple biometrics and are stronger, and they improve accuracy as well. And WebAuthn is just basically a secure web-based biometric authentication that is used on web browsers without exposing biometric data. Continuing on with Shamir secret sharing in what I was mentioning. Shamir secret sharing is basically a technique, and basically it splits a secret into shares. And what I've done is I've made it so you can split into 5 shares. And basically, to reconstruct it, you need a minimum number of those shares that were split. So, for example, in my project, you need 3 of those shares out of the 5 total shares to actually reconstruct your password, so you can actually then see your password and then log back in. So that's basically how the Shamir secret works in terms of recovery. And basically, I did this because this is more taboo than other recovery passwords. And basically, Shamir secret is mostly used in a bigger project and a bigger infrastructure, but I brought it down to this level because it actually recovers secrets very safely as well. In terms of zero knowledge authentication, zero knowledge proofs are just very interesting. Basically, the theoretical foundations by Goldwasser, and basically they just allow the user to prove that they know a secret without revealing what the secret is. Basically, in authentication, I can prove, or users can prove, that they know a password without that password actually sending to the server. And there are different types of interactive proofs and protocols that can be used for a secure authentication. And yes, that's basically some related works regarding zero knowledge authentication. In terms of research gaps, what I found in researching was basically they're just limited implementations in terms of integration of both biometric and zero knowledge integration together. Distributed recovery, like I said, it's a bit taboo to make in a small project like this, but Shamir secret sharing is used in bigger projects. And basically, in terms of research, what I saw was some missing things, such as a combination of something you know, something you have, and something that you are in zero knowledge systems. And what I've done is I've done something, implemented something you know, which is your password, something that you have, which is your device, and something that you are, which is your biometrics, whether your face or your fingerprint. And basically, innovation, basically what we've accomplished now is implementing biometric integration with zero knowledge proofs, Basically, we've integrated Shamir's secret sharing recovery systems using zero knowledge principles. And like I mentioned, we have client side encryption, which is always gonna be the main focus of this project. It's never, nothing is ever server side encrypted. It's always client side encrypted. Then the server side validation then works as well. Okay, now going to our experiments and the model. Basically, the architecture goes through here. Basically, the zero knowledge data flow is basically the user inputs their password, is then client side encrypted. Zero knowledge proofs is then used for validation and security. And basically, the server then validates that proof with a challenge anytime a user wants to then log in. And then for biometrics, same thing. Biometric user uses their biometrics, it then gets secured as well. And then Shamir recovery, basically the distributed shares, and then that can be used to recover your password. Some technology implementations in our front end, we use Next.js and TypeScript, which is a modern React feature. In our backend, we use Next.js API routes with our database, which is MongoDB, and it's a PostgreSQL. And basically, we use cryptography elements as well, such as web crypto, with our advanced encryption security. We're also using SHA, which is I didn't mention here, but also a hashing algorithm. And basically, for our authentication, we use biometrics and JWT for session management. And obviously, recovery is our Shamir secret sharing. We have three main pipelines, which basically, our first pipeline is our zero knowledge authentication system. And basically, in my ZKP system, the server sends a unique challenge during login, and then the client uses their password, which then combines with the biometric data to generate a proof. And basically, the proof then shows that they know the secret without revealing it. And then the server simply just validates the proof without ever knowing the password or biometrics. And then this then protects against leaks and attacks and data breaches. I also implemented a security feature for account lockouts and if there's 5 failed attempts, and also JWT tokens for session management as well. We also have password keys derived by our PBKDF2 with 100,000 iterations. And this is the SHA-256 hashing algorithm that I mentioned. And for the 100,000 iterations, basically what happens is it is less susceptible to brute force attacks. Our second pipeline is biometric integration. And basically the biometric component supports both face and fingerprint recognitions. And basically what I've made is a unimodal biometric system, and this project protects the biometric templates with zero knowledge proofs. So both biometric and zero knowledge proofs are implemented together, and even if the attackers breach the server, they will never know the raw biometric data to steal from it. And our third pipeline is then Shamir secret, which basically splits the secret into shares. So upon registration, a number of shares are going to be given to you, which is a total of 5. And basically each share is validated and comes with a checksum. And basically the database only stores the metadata, not the actual shares. So when a recovery attempt is then made, the user collects all the required shares. You only need 3 of those total 5 shares to actually recover your system. And as well, it can also be distributed. I didn't add it here, but we have a SMTP, which basically allows you to send these shares to other trusted devices or other trusted people. And basically, these are just cryptographic parameters that we used. And basically, we used several algorithms such as the AES, PBK, which is basically just our key derivation. as well as we have random generation methods as well for passwords, and SHA-256 for integrity verification as well. This is just what I mentioned in terms of before. We also have base 64. We also have array buffers, which allow for face API strings, or our method strings to be turned into bytes, and our encoder turns into bytes. We have salt generation. We also have array buffers, which then turn that into base 64 strings as well. In terms of Shamir secret, like I mentioned, we have 5 total shares and only 3 required, with a checksum as well. And that leads us to the results. What have we, with everything we've spoken about and everything we've done in the system, what have we actually gotten? So basically, my system was implemented and tested successfully. And basically, with the results, the zero knowledge proof works as expected. The passwords are all client-side created, and also client-side encrypted as well. That means the passwords never leave the client, or the client is basically your device and never leaves your device. And then biometric authentication uses fingerprints and face recognition, which is fully integrated and functional. The Shamir's secret sharing recovery basically has been tested, and all the secret are securely reconstructed and deconstructed with the required number of shares. In terms of our security results, basically what we have is there are no plain text passwords that are exposed to the server. It's 100% unique challenge generation. So this eliminates brute force attacks. It also eliminates various other attacks, such as replay attacks, so that your challenge generation is always unique, and no one can come in and claim as yourself. And basically, all ZKP proofs are validated correctly before stored onto the database. And basically, Shamir shares pass integrity checks as well. In terms of our results in performance benchmarks and some matrix, basically authentication speeds in terms of biometrics and password authentication are below 5 seconds. Since we are using MongoDB as our database, we have memory efficiency, and it can store up to many vault entries and many passwords. Recovery success, we only need 3 out of 5 shares. ZKP proofs are generated under 200 milliseconds. We've tested this, as well as biometric recognition and share reconstruction as well. And database operations are also quick and efficient as well. In terms of the UI results, we've used Next.js and Tailwind to make a responsive UI. We have biometric login, which is very good and secure. The recovery process is clear, but also requires a bit of explanation. And obviously, users can also see their login audit trails as well in the system. Just critiques and limitations on what went right. The ZKP has been fully integrated and been implemented. The biometric integration is successful. Shamir recovery is functional, and everything is secured and validated. In terms of what went wrong, and there's some limitations to the system. Facial recognition is sensitive to lighting. So if we have this method in the system which actually calculates the quality of your face scan, and basically it's very sensitive to lighting, so you have to be in a good environment. In terms of browser device compatibility with our biometrics, some devices may have fingerprints, some may not. And that's why I use them unimodal integration, so we can use both fingerprints and face recognition, just in case a device doesn't have either or. And basically, some performance overhead, since everything is done in client side, there's some stuff that we can optimize. And then basically, users may struggle to grasp Shamir recovery process, because it is a bit it is a bit somewhat complicated in a way, but everything is explained as they go through the process. The lessons I've learned while just doing this system is basically zero knowledge requires a big architecture. Truly, it's actually amazing how I've scaled it down to this size. Obviously, I've removed some stuff in terms of overcomplicated zero knowledge architectures, but zero knowledge really need a big architecture. Biometric systems must always have a fallback method. How I implement it is, if you don't have a fingerprint, you can use face recognition with your webcam, since every device mostly these days have webcams. You can also choose not to even do biometrics if your device doesn't have any of them. And basically that's how I've implemented some fallback methods. So basically, in terms of complex features like the Shamir, user education is needed in terms of how the system actually works, and testing is also essential as well, just to know that everything's working properly. Some future works that I've thought about is just optimizing it in case of client-side encryption. We can always optimize the performance. We can extend this to mobile devices, and we can actually make this mobile responsive. We can explore quantum resistant algorithms, which basically help in terms of breaches and also other trendy authentication systems as well. And then we can also use good penetration testing just to know that everyone's device and everyone's password is secure properly. In conclusion, what we've achieved is zero knowledge proof, biometric and Shamir recovery. And basically, this is also a good working prototype that implements all these three systems. And in conclusion, this project produced and demonstrates a privacy first password manager, which is practical and usable. And basically this then leads to future foundations that I've mentioned. And what we've done is a proof of concept, and it already shows that the next generation of password managers can be optimized, can be secure. And in conclusion, this is what we've done and this is what we have achieved. This is the results that we've gotten. These are the limitations. And in the beginning, I also talked about the reasons why we use ZKPs in the system for just a more secure and good architecture and system for securing passwords and credentials. Just in addition to the conclusion, this is also my references list. These are the different sources that I've gotten all my information from. It also extends to this page, where also includes other references as well. So these are all the references that I've used in my research and also in the project building as well. So that's my project. Thank you so much for listening and watching. Have a good day. Thank you.